The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@yvcc.edu and I will respond as soon as I can. All right, so eventually, today we're going to go on to section 8.3. But the first thing I want to do, I actually want to go back and look at one problem from your chapter 5 test. And this was problem number 14 on the chapter 5 test. All of you had a similar problem, but perhaps different numbers. So yours might not have looked exactly like this, but the idea is the same. So let me write it here. 8a squared minus 24b squared all over 72ab. The reason I want to do this problem is because almost everybody missed it. Almost everybody did it wrong. Almost everybody did it the same way. And I'm just kind of curious as to where it came from. All right. When you have a polynomial divided by a monomial, you take each term in the numerator and divide it by the denominator. 8 over 72 is 1 over 9. A squared over a is a over 1. So you end up with what? A over 9b. I think I did that right. Can't read my own writing here. Minus 24 over 72, you could take out an 8. Actually, you could take out a 12 and get, what, 2 over 6? Oh, you could even reduce it down to 1 over 3, couldn't you? Yep, 1 over 3, and then b squared over b is a b on top, so you get b over 3a. Let's see, did I do that right? 9, a over b, and b, yeah, okay. But what people did instead is they said, oh, 8 goes into this and this and this, and so they reduced it down to a squared minus 3b squared all over 9ab. And a number of students did that. And we didn't even talk about how to do that if you were going to do it. But I just wanted to point out that this is what you were supposed to do with it, not reduce it down through some other means, but separate it out, reduce each fraction. Okay, having said that, are there any questions? I didn't get any requests on email. Anything you want to look at before we go on to section 8.3? All righty. And I'm going to switch over to another screen. Let's see, give me a minute here. And I used this screen yesterday and it wasn't working. So hopefully today I tested it out and it supposedly was working. So we'll see what happens. All right. Okay, here. So can everybody see a screen? It says number 17 and there's a graph on it.
Yep.
Okay, great. All right. So we have this graph of this linear equation, and part 17 has, let's see, part A. That's cool. Don't do that. Okay. Let's see if it's going to behave here. There we go. Part A says f of -2. Part B says f of 0. Part C says the value of x for which f of x equals 4. And part D says the value of x for which f of x equals -2. Now, in yesterday's assignment, we had very similar questions, except that instead of giving us a graph of the equation, and this is the graph of f or f of x, they give us a graph. So instead of giving us, instead of giving us an equation, they give us a graph of the equation. But the idea is still the same. So the first question, it says, well, it doesn't really look like it's written as a question, but it says, let's see, refer to the given graph to find each value. So let's find f of -2. What is that saying? That's saying, go over here to the graph, okay, to this graph over here, and find y when x is -2. So where on this graph is x equal to -2? Right here. So what is the corresponding y value right there? What is that? Anybody?
It looks like -4.
And it is. So f of -2 equals -4. All right. Basically what that's saying is the graph contains the point -2, -4. They're giving us the x value. Find a point on the graph that has that x value. Tell us the corresponding y value. All right. Any questions about that? Okay. Then it says find f of 0. So where on this graph is x equal to 0? Right there. What's the corresponding y value?
That would also be 0.
Right. So when x is 0, y is 0. Any questions about that? All right. Let's look at this third question. It says, find the value of x for which f of x equals 4. Now, f of x equals 4. So that's another way of saying y equals 4. So where on this graph does y equal 4? Right there. Okay, y is 4 there. What's the corresponding x value there?
That would be 2.
Right, so x equals 2. So given y, find x. And then finally, the value of x for which f of x is -2. Where is y equal to -2? Right there. Oh, wait, excuse me, on the graph right there. So when y is -2, what's x?
That would be -1.
Right. So all we're doing is the first two, part A and B, they're giving you x's and saying, look at the graph and find the corresponding y values. Part C and D, look at the graph, given the y values, find the corresponding x values. That's all this is, okay? If you're not getting this example, speak now, because this is pretty much one of the big deals of what we're looking at today. We're just going to look at several examples of this same idea. Okay, let's go to number 18. And here, part A says to find s of -3. And let's see, this function is s. Okay, then we're to find, let's see, part B is s of +3. Part C, the values of x, the values of x for which s of x equals 0. And part D, the values of x, oops, all right, come on here. X for which s of x equals 3. Okay, now there's a slight difference in the directions on this problem. It says the values of X. So that implies there's going to be more than one input, more than one X value having the same Y value. That's okay with a function. You can have two people with the same birthday, two inputs going to the same output. All right. So see here, S of -3. So when X is -3, which would be what right here, what's Y?
That would be 2, right?
2. All right. Part B, when X is +3, what's Y?
5? Would
No,
it be 5? No, 4, right?
yeah, 4, yeah. Yeah, the hash marks, this is 5 and this is 10, etc. Okay, all right.
Yeah.
Now, let's see here. I'm going to clean this up. So I'm going to undo a bunch of this stuff to go back. Okay. So now let's take a look at this problem. I just wanted to have a clean looking graph there. The values of X for which S of X equals 0. So S of X is another name for Y. So where on this graph does Y equal 0? For what values of X does Y equal 0?
It looks like -1, 1, and 5.
Not only does it look like it, but it is. Good. So we'd say X equals -1, 1, and 5. So when X is -1, Y is 0. When X is 1, Y is 0. When X is 5, Y is 0. You got 3 different inputs with the same output. 3 different people with the same birthday. Maybe they're triplets, who knows? All right, you okay with that? All right, now, let's see, I gotta look at something here. I didn't draw my graph quite accurate enough, so I'm gonna do a little bit of manipulation here. Okay, all right. So the values of X for which S of X equals 3. So where does Y equal 3? Well, that would be right here, wouldn't it? That's Y equals 3 right there. Oh, so what values of X make Y equal to 3?
2 and 4, right?
Right. There you go. And that's it for that problem. Any questions? Okay, let's go on to number 20. And let's see, part A says find H of -3. Part B says find H of 4. Part C says the values of X for which H of X equals 1. And part D, the values of X for which H of X equals 0. Oh, wait, my bad. Sorry, apparently I lost you. Is everybody back?
Yeah, it froze.
Yeah, sorry about that. And let's see, I think it's still recording, hopefully. Okay. All right. So, same questions. H of negative 3. So when x is negative 3, what's y?
Is it +4?
It's positive 4. Good. H of 4. When x is 4, y is
Looks like it would be 3.
Yep. All right. The values of x for which h of x or y equals 1. Where does y equal 1? Right there and there. So what values of x? X would be
0 and 2.
Yeah. The value of x for which h of x is 0, for which y is 0. The value. So where is y equal to 0? When x is
1.
1. Okay, you see what's going on, folks? It's not that tough. Don't make it difficult. We're just completing ordered pairs by looking at the graph.
I have a question.
Yeah.
So what if it asks us to find a point where there isn't a line, or will that ever happen?
So let's say, let's make one up here. This is part E. The value of x for which h of x equals -2. Okay, which would be right down here. None.
Oh, okay.
So it could happen. That's what your answer would be. There are none. Okay. We good to go on to another example? All righty. Number 24. Here it says, find the domain and range. And we're going to use interval notation. Okay, which we talked about yesterday. So the domain is the x values. The range is the y values. Okay, so first of all, let's take a look at, let me change this to red. What does that arrow imply? Well, it implies that this thing keeps going up and it keeps going over, right? What does this arrow imply? It keeps going up and it keeps going over. So this thing extends on and extends on. So if the domain is all of the x values, what x values would be included on this graph?
None?
Let me ask you this. What's the x value of that point? This point right there.
-2?
Oh, but you said none. But there's x equals -2.
Isn't it negative infinity to infinity?
Yes, it's all real numbers. Are you seeing that? Pick a point on this, or pick an x value. 17. Okay, if x over here is 17, if this graph continues on, it's going to include x is 17. How about -40? Well, if this graph continues going up, but also continues going over, isn't it eventually going to reach -40? So your domain is going to be all real numbers. You see that?
So on WebAssign, we would just put all real numbers, or we had to write the infinity, or how would we even write infinity?
Use interval notation. So this is how you would write that. Okay. Now,
Does
Okay.
WebAssign have a
Yes.
function for writing in infinity, or no?
Yeah, that's what I was trying to ask.
It hasn't been an issue in the past. I don't remember if it has a negative infinity sign, or I think it may be a case of where it gives you some options to choose from. I think that's kind of how they do it. So, you know, you'd have like A, B, C. A is maybe negative infinity to infinity. B is 7 to 42 or something. So I think you don't have to write this. I think you just have to choose the correct answer. Does that make sense?
Yeah.
It hasn't been an issue. And so usually if there's something that has been, I would have heard about it. Okay, now, careful. The range is all the Y values included on this graph. Let me ask you this. Is there a point on that graph that has a Y value of -5? A Y value of -5.
No.
So -5 is not in the range. Is there a Y value of 2?
No.
How about a Y value of 7?
Yes.
Okay. 6?
Yes.
3?
It looks like.
2.99999999.
No.
So where does the range start?
At the Y value of 3.
Right. Are we including the Y value of 3?
I think so.
So we use brackets. Parentheses mean you don't include the endpoint. With negative and positive infinity, there is no endpoint, but this includes 3. Okay, so then where does it go? Does it go up from there?
Yep.
How far up does it go?
Well, forever.
So what's forever?
Infinity?
Yep. But again, we don't close up infinity. So there's the range using interval notation. Starting at 3, going to infinity, including 3. Okay.
So when we're gonna write for the Y, we just put the bracket instead of the parentheses.
No, it's not because it's a Y. It's because specifically Y equals 3 is included on the graph. But the whole idea of infinity and negative infinity means you go on forever. Well, if you go on forever, there is no specific endpoint. Let me do this. I'm going to manipulate this thing a little bit to give you to show you how things would be different. Okay, let's say that the graph looked like this. Okay, so that open circle means that that point on the graph is not included. Okay. So now, is 3 in the range? No, it's not. Is 3.0000001 in the range? Yes, it is. But how do I show that 3 is not included? What I do is this. So that means everything after 3. So it had that notation, parentheses or brackets, has nothing to do with whether it's domain or range. It has to do with whether that point is included or not. Okay. Are you seeing the difference there?
Yeah, so if it was if it's not included, I'm gonna put parentheses in the 3 comma. And if it is included, I'm gonna put the bracket.
Yes.
Okay.
Now, me having manipulated this thing and changed it, it also is going to change the domain now. So looking at this new variation with this hole here, now the domain would be from negative infinity up to, but not including 3, along with 3 to, to infinity. Ah. Okay.
Okay.
All righty. Let's go on to another example. Number 26. Again, we are to find the domain and range. Could my handwriting get any worse? Probably not. So domain range. Okay, now these arrows going down like this. So it means that the graph continues to go down, but it also continues to go over. This is going down and over. So what's the domain for this graph?
X would be equal to infinity, right?
So that would be over here. What about over here?
Also negative infinity.
So it's going to go from negative infinity to positive infinity. So in other words, it includes all real numbers. All right.
Mm-hmm.
What's the range?
It looks like all numbers below -1.
Would it include -1?
Yes.
Yes.
So how would you say?
So would you
everything-
put,
Go ahead. What?
would you put negative infinity and then comma -1 with the bracket?
Yes, you would. Good job. Everybody see that? So we're including -1 and everything less than that in the range. So that means no matter what you put into the function, you can put any real number in for the input, the domain, all of your outputs are going to be less than or equal to -1. You're never going to get an output that's above -1 because that would be up here and it doesn't happen. All right. You good to go on?
Yeah.
All right, this is number 65.
This
And
one looks funky.
yeah. Actually, wait a second. That isn't 65. That's 67. I remember now. I changed it. Okay. 67. These numbers are from the textbook. If you're wondering where I'm pulling these numbers out, it's because I wanted to have the graphs ahead of time, but not the information that we want to find. Okay, so it says find G of 1, and this is the graph of G. So part A, G of 1, part B, G of -4, part C, the values of X for which G of X equals 4, and part D, the domain and range of G. So we had some earlier problems where we found specific values, then we just had a few with domain and range. This one has all of them. So G of 1. So when X is 1, what is Y?
It looks like 2.5.
Yeah,
what
we'll
I'm
go with
seeing.
that. Yeah, it's kind of, we'll say 2.5. So, yeah. And you're not going to get something in WebAssign where you're going to have to approximate. It's like, well, I don't know. Is that 2.4? Is that 2.5? Okay. How about when X is -4?
It looks like -4.
Mm-hmm. Yeah. When X is -4, Y is -4. Okay. Any questions there? Part C, the values of X for which G of X, another name for Y, equals 4.
That would be -2 and +2.
Correct. Okay. What's the domain of G?
From the angle of the arrows, I'm assuming all real numbers.
And the range?
Including +4 for y, it's everything below that, it looks like.
So starting at the most negative would be what? How would you write that? You wouldn't actually start with 4, you'd end with 4.
I see.
So what would you start with?
Negative infinity.
Correct. Yeah. So your domain goes from smallest to largest. Your range goes from smallest to largest. So domain goes across in this direction, range goes up in that direction. You start with a negative and go to the positive. Okay. We good to go on to the next example? Okay. Number 72. And here's what we're supposed to do with problem 72. It says, determine whether each graph is the graph of a function. If it is not, find two ordered pairs, and there may be more than one set of two ordered pairs, but find two ordered pairs where more than one value of y corresponds to a single value of x. And let me help you through this one. Okay, this is not a function. For instance, let's take a look at, let me go back to red here, this point and this point. The top point, what are the coordinates of that point? X and Y, what are the coordinates?
That would be 2 and 2.
Okay. The bottom point, what are the coordinates of it?
2 and -2.
Oh, look, you've got the same X going to two different Y values. So it's not a function. There's an equation that represents the graph. There's a graph there. There's domain and there's range and all that stuff, but it's not a function because you've got one X value going to more than one Y value. Do you see that? If one input has more than one output, it's not a function. For a function, each input has exactly one output. Another way of looking at this, I want to talk about something called the vertical line test. And if I, let's see, sorry about that. Boy, maybe I should pay my cable bill. All right, are we still recording? Let's see if it's still, yeah, it is. Okay. Okay. And so what I wanted to do is I wanted to go back to this. Okay. If I can draw a vertical, that's not what I want there. If I can draw a vertical line through the graph, any place on the graph, and it cuts through more than once, that means that for a given X, there is more than one Y. So the vertical line test is to see whether it's a function. This fails the vertical line test, so it's not a function. If I draw vertical lines through the graph, at least one place, in fact, many places, there's more than one Y value for a given X value. Let me do this. Let's go back a ways. Let's take a look at this picture right here, okay? And I want to talk about this vertical line test. Is there a vertical line that I can draw somewhere here on this graph that cuts through the graph more than once? No. For each X, there's only one Y. It's a function. This one, same thing here. For each vertical line I draw, it never cuts through the graph more than once. So it's a function. Now let's take a look at this. This is supposed to be a circle. How about this? Does this pass the vertical line test? No.
No.
For instance, how about right there? It fails. When X is 3, Y is what? -2. And when X is 3, Y is -6. So what you've got is 3, -2, 3, -6. There's a set of ordered pairs that contradicts how a function works. For one input, there's 2 different outputs. Somebody has 2 birthdays. Remember, we talked about that whole idea a couple days ago. So this is not a function. All right with that? Any questions? I think this is all the examples I had. Let me see there. Yeah, that is. Okay, well, that's what I've got for you today, 8.3. I'll be back at 1:15 this afternoon if you have some questions, and hopefully the internet will be working better then. But otherwise, I will see you all later.